What's up, guys? Welcome back to Vanover Machine and Repair, and in today's video we're going to be doing some machining over on the beautiful pacemaker lathe. We have this nice drive hub assembly that needs to be machined down for this bearing fit, and this is for one of my favorite customers. Let me bring you in close and give you some of the details. Taking a closer look at the part, the main issue with this piece is when I got it from the customer, the bearing slipped off. Now, I don't have all the details, but I'm told that the bearing should be an interference fit on this shaft, and the old bearing fell off on one of these, and on the other one it was nice and tight. So the job for us is to come in here and to weld this out, machine it down, and make sure we have a nice interference fit. Now, on face value, this job seems like it'd be fairly simple, but there's several things that can make this job be quite a bit more complex, and most of that has to do with fixturing. The first thing is our lathe, even though it's a large, small to medium lathe, this is at the capacity of our machine, so it will fit, but we have about a ½ inch to spare, so that's going to make it quite interesting. And the second thing is we do have a keyway right here, so if for some reason we are welding this up and we backfill that keyway, we need to remachine that. And because of the shape of this, we'll have to clamp it from the side and come in here with a really long end mill and clean that up. So it's just going to be a little bit more difficult from a fixturing standpoint. But aside from that, that's most of what machining is. The welding and machining itself should be relatively straightforward. So with that said, let's talk about the bearing and the fits. For this job, we're going to be using this SKF bearing here. Let's get this guy opened up. It's a nice high quality unit, probably pretty pricey. And in terms of the fits, what I like to do is you can go in the machinery handbook and get a chart that gives you a range. That's going to be more than sufficient. But I like to call the manufacturer. I called SKF Tech Support. They gave me the numbers I needed, and now I feel really comfortable with the job, making sure I can get the exact fit on this shaft. So I went ahead and just made this cheat sheet for me. It's 10 minutes on the computer, allows me to be at the machine, minimize errors, so I can see that the bearing nominal size is going to be 85 ID, 150 OD. The range that they gave me was here, 3.3474 to 3.3483, and that is going to give me a 1 to 1.9 thousandths oversized fit on the shaft, so that, or a 1 to 1.9 thousandths press fit from this bearing to that shaft. So this sheet will just kind of help me be organized and efficient over at the lathe. So with that being said, we're going to start by getting the drive assembly cleaned. It's pretty greasy, and then we'll move over to the lathe. With the part cleaned up, let's go ahead and take a measurement and see where we're at. .181. Get out my calculator here. 3.181 minus 3.347 gives us about 163 thousandths of undersize. And when we put the bearing on there, yeah, we definitely feel that. That's really bad. So we're going to do a decent amount of build-up here. We did go ahead and test the material. This is a cast steel, so luckily it's not cast iron. I just turned it over to the other side, did a tack weld on it, hit it with a file, it skates good, and then I also did some grinding sparks just to double check. So other than that, we're ready to get this set up in the lathe and get it indicated true. We'll probably use a faceplate just because of the diameter and go from there. We got the part indicated in and everything's looking good. It's within a few thousandths, more than good enough for what we're doing here. Unfortunately, we only have 2 bolt holes holding this flange on. Ideally, you'd probably want 3 or 4, so we are gonna take it easy. What our goal here is to come in here and clean this up with our lathe tool. That's just gonna give us a better surface to weld onto. Now you probably could come in here and weld on top of this, but in my experience, a lot of times this surface is really hard from getting burnished or worn. So getting that cut down just creates a cleaner weld and a better end result. It also allows us to stack the weld up just a little bit thicker so the weld has a little bit more thickness, which can make the repair be a little bit more durable. So with that being said, let me get the tool in here and we'll get that undercut. We're gonna preheat our parts while we take lunch. This is gonna give us a nice even preheat and it's gonna allow us to do some work while we're taking a break. You could do this with a torch, but since we have in the oven, we might as well use it. Let me see if I have a profile in here. There we go, cast iron or cast steel preheat. We're gonna hit start, no delayed, and we're gonna heat up to 400 degrees Fahrenheit. It's gonna keep it there for 2 hours. We won't let it sit there the whole time. And then we'll come and put our part in, take some lunch, come back. The part should be 350, 400 degrees, and then we can start welding. All right, we've let this sit for 2 or 3 hours. We're gonna take it out, bring it over to the bench, and get it welded up. Should be nice and warm. All right, we got a plug made for the back. We're just gonna tack that together. That'll give us something to grip on. What the heck? What's going on here? Why is it pooping? We got that fully welded out and I was struggling with the welder. This result is not as good as I wanted. Overall, it'll be 100% fine, but I tried with my small welder. This is a real small piece, and basically after maybe 1 round, it just kept shutting off. I think it was too much of a continuous run. We switched to the big welder and it looks like that I was having problems with my power cord. So the wire was actually shorting on the box of the feeder, and so I was just running basically out of time, and I didn't really film a lot of that because I wanted to try to keep as much heat in the piece and sort of work, you know, against the clock to get this welded out. And I had the welder set up for a previous job, and I usually just leave it set up And so it's a little bit on the thick side, but we did get good penetration, and it is gonna turn out fine. It's just not super attractive, and it didn't lay down super flat. So it is what it is. Sometimes things don't go as planned. We got this indicated in, it's running within 1/1000th and a half. So we're gonna come in here and machine this down. We have plenty of material here, and then we may have to clean up the threads, and we'll kind of go from there. Seems to be machining quite nice. Just trying to take it slow. .533. Well guys, I'm a little bit disappointed here. So we're about 10 thousandths away, and if this was a normal shop, we would send it. And I probably should from a business standpoint, because we're gonna invest a bunch more time to make it not that much better. But I don't know what to tell you other than I like to send good work out the door. And unfortunately, I was struggling with my welder, and I had to switch between two welders, and it caused an issue, right? I like to do things as good as I can, but sometimes life happens and you have problems. So the problem that we had was when I switched welders, I had a little bit of spatter, a lot of spatter, and I tried to go over it to clean it up, and I just couldn't do it. So overall, the surface is clean. There's maybe 1 or 2 inclusions, yeah, 1, 2. But the reality is you can see spots where I've touched this up because I welded this in 2 steps. And there's just no way to avoid that other than machining it down and trying again. And that's really unfortunate, but guess what? I'm gonna do it because I want it to be done right. And at the end of the day, when this leaves my shop, I wanna know that I gave it my best effort, and we're in the best possible position. So everything that you've seen up to this point, we're gonna redo. I'm gonna machine it down a little bit, we're gonna re-weld it, we're gonna put it in the oven. It's probably another 4-hour ordeal. I'll bring you back when we're at this point and we have a nice consistent weld, and we'll take the last 10 or 15 thousandths off, but I want it done right. Oh, wow. You know what? We are MIG welding this. Well guys, 4 hours later, we ended up with this beauty of a mess. And I'm showing this to you guys because this is reality. Sometimes you have a bad day, and sometimes your equipment gives you a hard time, and what we're looking at here is a bit of both. So my welder, I figured out that one of the legs was shorted on the connector where the 2 like extensions lock together. I was able to fix that. I don't know if that caused an issue with my feeder or my feeder just happened to go bad at the same time, but I was able to get this welded, but my feeder is intermittently not feeding. And it's not an issue with burn back or anything like that. You'll hit the trigger and it won't actually spin the gear on the feeder. Sometimes it works, it needs to be replaced. I've already rebuilt the electronics once, and it's time to move on to a new unit. With all that behind us though, this is what we're left with. And we started out good. I went through the whole process, but we had a little bit of issues because of that. And I went over it again and again to try to cover that up and really try to, burn out most of the issues. And, we ended up going over the thread, which was definitely not my plan. And here at the end, it was blowing out. And, I'm using the wrong setup to do this. The setup that I have in that machine is really nice for doing flat, thick welds, but for whatever reason, it doesn't do as good on a thin edge. It's just the way I have the machine set up with the wire and everything. I have it kind of set up for a certain job, and yeah, I'm just struggling with the machine, and this is also just me having an off day. So this is how it is. I think we can still salvage it. We have way too much material on here. So we're gonna go in, machine it down, and clean up the end. Luckily, while I was welding this, I stopped, took measurements of the thread, took the pitch, took the measurements of the slot and the depth. So we have all that data. It might end up working out better because you'll get a new thread here, whereas that old thread was workable, but it had some parts missing and stuff. So hopefully we can salvage this and turn this pile of poop into a good part. So with that being said, I'm gonna come in here. It's gonna take a while. We'll go slow and we'll get this roughed back down. Three, 8, 5, 7. Here's the final result. Surface finish is not that great, but the sizing is correct. There we go. 347 and 7/10. Our window was 347 and 4/10 to 348 and 3/10. So that's dead in the middle of our range. I really wish I didn't have a couple of these very minor inclusions, but we're not gonna redo it for that. So we're gonna come in here and clean up this disgustingness here and turn this down and rethread this and then do our slot. Just trying to clean up our mess on the inside with the boring bar. All right, we're gonna make our groove for our thread relief. All right, we're gonna do our threading. 12 TPI, as you can see, we have a slight inclusion there and a couple others. We'll see how it goes since we're gonna be threading. We might cut into that. Also, you can see the color discoloration there. That's just different hardnesses from us welding on this high carbon steel. So this does kind of suck. We're able to cobble this together and probably save this part, but this is definitely not a fun one. All right, so I'm just gonna zero off. Okay, I guess the part is definitely not great, but I'm trying to save it instead of redo it for a third time. Do a scratch pass. We're gonna need lots of lube on this. Take it slow. Threading with the top slide, not the compound, for everyone who doesn't like that. Haven't broken an insert yet, kind of surprised. Cutting through weld and interrupted cut. All right, we ended up getting this finished out late last night. Last step is to come in here and put our key. We have marked a spot here. We have a nice inclusion in the thread. That's the only real inclusion. So if we put a flat there, it should get rid of that. And we should be looking real good. So we're gonna get this out of the machine, get it over into our new milling machine and mill that keyway. We're over here at our new to us Fryer MB16. It's a manual / CNC bed mill. And I have a custom shrink fit tool holder set up, and we have this in our big vise here. So we're gonna come in here and just cut our little keyway. This is the first job I've done on this machine, so I'm learning. I'll just be jogging the machine over on the control panel, and we're running 1,000 RPMs, 4 inches a minute. So we'll see how it goes. Well, we knocked this part out and it's all finished up and ready to go. Was a little bit hairy there for a little bit, but I think we made a decent recovery considering the circumstance. I do need to get a new welder, so I'm trying to figure out which unit to get. Either I'm going to replace the feeder on that 300A, or I'm going to buy an inverter MIG welder that's industrial duty. Haven't quite figured that out yet, but I think considering where we were and given the application, this will work out perfectly fine. The bearing is a nice fit as it should be. The thread should be a little bit better than before, and we went ahead and got that slot cut and got to use our brand new CNC machine. So overall, I'm happy to have this done. I hope you guys enjoyed this short little video. If you guys have any questions, leave them down below in the comments, and we'll see you on the next one.